All right, people. I believe everybody is doing great, nice, and absolutely fine. So, welcome to Unacademy NEET English. I believe all of you are doing great, having a good time. So, guys, please let me know in the chats if I'm perfectly audible, visible to each and every single student. Okay? Let me know in the chats if I'm perfectly audible, visible to each and every single student. Okay. And let everybody join, let everybody come. We are going to start the session accordingly, and I am going to start everything from the scratch. We have the center of mass chapter today. Okay. I'll be sharing the PDF of the previous class also. That is work, power, and energy. I'll be sharing that PDF also by today itself. You don't have to worry about that. Okay. Make sure everybody of you smash the like button because liking the session is extremely mandatory. So, everybody out there, do like and smash this session. Everyone. Okay. And most importantly, guys, I'll be starting from the scratch. If you have not studied the chapter before, okay, doesn't matter because you would be able to understand each and every single thing. Okay. Okay. Is that clear? Okay. Yes. So, let's dive into this particular session. Okay, we'll be finishing the session, I would say, in 3 to 4 hours because this is the high weightage chapter. I'll have to start from the scratch and I'll have to show you all the problem patterns, whatever is there in this particular chapter. Okay, okay. Now, guys, let's dive into the session. Let's start the session from the scratch. I would want you guys to listen to me very carefully. You would be able to understand each and every single thing. That is my guarantee. But you need to listen to this very carefully. Okay. 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 Now, guys. Now, guys. Let's move on to the chapter that is center of mass. Let's move on to the chapter that is center of mass. Now, guys, listen carefully. Listen carefully. When it comes to the center of mass, what does center of mass actually mean? Listen, guys. Let's suppose if I say I have got this pen over here. Okay. And I need to balance this pen at one single point. Let's find that point. Okay. I'm, sir, taking this particular point. No, it is not balancing. I'm taking this particular point. No, it is not balancing. Now I am balancing this point pen at this particular point. I call this as a center of mass. Simple definition. You don't have to go in much detail. Okay. So we say that point where whole mass of the body can be assumed or can be concentrated. Okay. So if you have to hold this pen or hold any body at one single point, that is going to be center of mass. That is going to be center of mass. Okay. So my dear NEET aspirants, it is that point where whole mass of the body is concentrated. Okay. Okay. I'll write over here that point where whole mass of the body can be assumed. Can be assumed. That point where whole mass of the body can be assumed, that is what we call center of mass. Like if I say I have got a rod over here, if I'm saying I have got a rod over here, this is the rod that I'm having. Okay. This is the rod that I'm having. Okay. This rod. Sir, where can I assume its center of mass? You can assume its center of mass at the center. You can assume, if you have to assume whole mass of the body at this particular point, that will be center of mass. Okay, that will be center of mass. Okay, okay. Now, my dear NEET aspirants, I have mentioned a point over here. I have mentioned a point over here. Please take a look at this particular point. Center of mass can be outside or inside of the body also. Doesn't matter. Center of mass can be outside of the body as well as inside of the body. Let's suppose you have a ring over here. This is the ring. So you can consider its center of mass at this particular point. At this particular point. At this particular point. And one more important point I have mentioned over here. Center of mass lies near to the heavier object. Center of mass lies near to the heavier object. Like. If I say this is a body over here, we say more mass of the body is towards right. If you say, sir, less mass is present towards on the left, more mass is present on the right. So center of mass will shift towards more mass. Center of mass shift towards more mass. Similarly, if let's suppose I have a square plate over here, its center of mass can be taken at this particular point. Okay. Like you have a mass over here, my dear NEET aspirants. You have another mass over here. These are the 2-point masses separated by some distance. If somebody asks you, where can you assume its center of mass? You say its center of mass can be assumed at the center, just outside of the body. Now, if you have 2m mass and if you have m mass, in that particular case, center of mass will be near to 2m mass, near to 2m mass. It will shift near heavier mass. Please tell me in the chats if this is crystal clear till over here. Everybody, guys, tell me in the chats if this is crystal and clear. I need the signal in the chats with the fire emojis if this is crystal and clear. Everyone means everyone. Weather in Kashmir is very good right now. Okay. It is good. Tell me, is this clear, my dear NEET aspirants? So that point where you can assume whole mass of the body, that's what we call center of mass. Okay. That point where whole mass of the body can be assumed, that is what we call the center of mass. As simple as that. As simple as that. Okay. Session duration is going to be 3 to 4 hours. Now, my dear NEET aspirants, let's take a look at this particular point, what is mentioned over here. Let's take a look at this particular point. Location of center of mass. What does location of center of mass? How do you exactly find the location of center of mass? Okay. Okay. The position of center of mass, I would say. Exact location, exact position, exact coordinates. Now, my dear friends, in this particular case, I have taken 2 masses. This is M1 and this is M2. I'm taking 2 masses, M1 and M2. This M1 is at R1 distance and this M2 is at R2 distance, okay, from the origin. Let's suppose this is y-axis, x-axis. Don't get confused with y and x. Just I'm taking 2 lines over here. So from this point, it is at R1 distance. Its position vector is R1 and its position vector is, I would say, R2. Or you can understand it like this. Coordinates of this point are x1, y1 and z1, this mass. Let's suppose it is like, if you have a mass over here, its coordinates are 2, 3, 4. So x coordinate is 2, y coordinate is 3, z coordinate is 4. That's it. That's it. X coordinate is 2, y coordinate is 3, z coordinate is 4 in this particular case. Okay. Similarly, my dear NEET aspirants over here, if I say you have 2 masses, x1, y1, z1. You have x2, you have y2 and you have z2. x2, y2 and z2. And in this particular case, my dear NEET aspirants, you have to find this its center of mass. Like over here, we were generalizing this over here. You have mass m, you have mass m, their center of mass will be exactly at the center. But what will be the coordinates? How do we find the position, exact location? That is what we need to find in this particular case. Now, guys, Listen to me very carefully. We say R1 and R2 are the position vectors of M1 and M2. If we have to find the position of center of mass, I would simply say position of center of mass. That will be this RCOM. How do you find it, guys? Listen to me very carefully. It is going to be M1 R1. M1 R1. Let's suppose here, this is center of mass. If we are assuming this as center of mass, sir, what will be its position with respect to the origin? Sir, this R I am finding, so RCOM will be M1 R1 plus, I would say, M2 R2. Whatever is the position vector of this, whatever is the position vector of this. I'll show you the questions also. Don't worry about that. Right now, please understand what I'm trying to say. Divided by, I would say, M1 plus M2. M1 plus M2. This is the position of center of mass where, like this is what we call the position of center of mass. Okay. Now, guys, understand one more important thing. Like you have, in this one, you have X coordinate of this one, Y coordinate of this one, and Z coordinate of this one. Similarly, you have X2, Y2, Z2. These are the coordinates of this mass. These are the coordinates of this mass. If you have to find the coordinates of center of mass, guys, see. I'm saying coordinates of center of mass. If you have to find what? Coordinates of center of mass. See, when it comes to the X coordinate, sir, how do we find the X coordinate? Listen carefully. X coordinate is simply going to be, that is M1 X1 plus M2 X2 divided by, I would say, M1 plus M2. Like X1 is the X coordinate of first mass, X2 is the X coordinate of second mass. So how do you find the X coordinate of the center of mass? You'll say, sir, M1 X1, M2 X2 upon M1 plus M2. Okay. Then, my dear friends, if I say Y coordinate of center of mass, Y coordinate of center of mass is going to be M1 Y1. Mass of first, Y coordinate of first. Then we say M2 Y2. Mass of second, Y coordinate of second. Then I would say M1 plus M2. Please, right now, remember these formulas. I'll be showing you the questions also. That will crystal clear every single thing. Okay. And similarly, if I say Z coordinate of center of mass, how do I write that? That is going to be M1 Z1 plus, I would say, M2 Z2 upon, I would say, M1 plus M2. Okay. These are going to be coordinates of center of mass, and this is going to be the position of center of mass, this one. Okay. Yes. I hope this is crystal and clear to each and every single student. There is no doubt in this one. Guys, tell me in the chats if this is crystal and clear. Everyone means everyone. Quick. With the fire emojis, if everything is crystal and clear. I'll make you understand with the questions also. Please don't worry about anything. You would be able to understand each and every single thing. That is my guarantee. But please, right now, listen to whatever I'm saying. Okay? 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 Yes, absolutely. Absolutely. That's great. That's great. Okay? Yes, M2R2, M2R2. That's great. Absolutely great. Now, my dear NEET aspirants, let's do one thing. I need to tell you a small concept over here. What is that? That is. See guys. Let's suppose if you have mass M1 and if you have mass M2. These are the two masses that you are having over here. And we said distance between the two masses is, let's suppose, r. This point over here is center of mass. This point over here is center of mass. Now, my dear NEET aspirants, this is R1, this is R2. This is R1 and this is R2. So, R1 means distance from center of mass to M1, distance from center of mass to M2. And in this particular case, my dear NEET aspirants, I'm just telling you one thing. What is that? This M1 into R1, this M1 into R1 will be always equal to M2 into R2. This M1 into R1 will be always equal to M1 into M2 into R2. What does that mean? That's mentioned over here in this statement. That's mentioned over here in this statement. We say center of mass divides the system. System means this entire system into two equal moment of masses. Moment of mass means M1 x1. This mass multiplied by that distance which is still center of mass. Mass multiplied by that distance which is still center of mass. Okay. Mass multiplied by that distance which is still center of mass will be equals to M2, this mass into x2. This is what we call moment of mass. This is what we call moment of mass. Moment of mass. So whatever is the moment of mass on the left side, same will be on the right side. Okay. Okay. So in this particular case, my dear NEET aspirants, in this particular case, we say center of mass divides the system into two equal moment of masses. Is this clear, guys? Please tell me in the chats, everybody out there. Is this clear? Tell me, everybody out there. Is this clear? Is this clear? Yes. Now, let's first try to look at the questions. Then everything will be sorted. Take a look, my dear NEET aspirants. Take a look, my dear NEET aspirants. I have got over here a question. The question is, two particles of mass 5 kg and 10 kg. You have got two particles of mass 5 kg and 10 kg. Okay? Yes. Are attached to the two ends of a ridged rod. Okay? Yes. Let me just make it over here. You have got over here 5 kg and you have got over here 10 kg. 5 kg and 10 kg. This is the 5 kg and 10 kg attached to a ridged rod. A ridged rod is 1 meter. 1 meter in distance. Okay. Now, my dear NEET aspirants, the further question says, with a negligible mass, the mass of the rod is negligible. It is not, there is no mass of the rod, negligible. You can neglect it. The center of mass of the system from 5 kg particle is nearly at a distance of. You have to find the location of center of mass from which particle? From 5 kg particle. Listen to me very carefully. I'll make you understand. See, guys, you have got over here 5 kg particle. You have got over here 10 kg mass. And they are attached by a rod. They are attached at the ends of the rod, that is 1 meter. You have to find the location of center of mass from 5 kg. If they are asking you to find location of center of mass from 5 kg, my dear NEET aspirants, listen carefully. You will be considering this at origin. If they are asking you to find from 10 kg, you will be considering 10 kg at origin. That is 0, 0. Okay. Now, my dear friends, since the two masses are on the x-axis only, they are lying on the same line, you will be simply finding their x coordinate. Okay, because their center of mass will be on the x-axis only, na? Let's suppose if this is y-axis, this is x-axis, their center of mass will be also on the x-axis. So when it comes to the position of center of mass, it is going to be simple. Sir, that is m1x1 plus I would say m2x2 upon I would say m1 plus m2. Yes, sir, absolutely. m1x1 plus m2x2 upon m1 plus x2. And if this is at origin means 0, 0, could you please tell me this mass is at what distance? I would say 1, 0. Okay. Because it is at x is equal to 1 meters. So you'll be simply writing over here m1x1. What is the mass of first one? That is 5. And what is x1? That is 0. So position of 5 kg is 0. Then we say m2x2. M2 is 10. And x2 in this particular case is 0 upon m1 plus n2. So 10 plus 5, that is going to be 15. Okay. Now in this particular case, this is going to be, I would say, this is 10 into 1, 10 into 1 over here. Yes, 10 into 1. So this is going to be 10 divided by, I would say 15. That is going to be 2 divided by 3 meters. And I would say that is going to be simply 66.66 centimeters over here. This is going to be, or 2 by 3, you can keep it like this, 66.6 centimeters. Okay. Keep it 2 by 3 meters only. So this is basically the position of the, this is basically position of the center of mass. This is basically position of the center of mass. Okay. Okay. Yes. So why did I apply, sir, this formula? Because the two masses were present on the x-axis only. So their center of mass would be also on the x-axis. That's why I applied this x coordinate formula. Okay. Because this one is going to give you the x coordinate of center of mass. This one is going to give you the y coordinate of center of mass. This one is going to give you the z coordinate. And this is the general form. This is the general form. That is this position of center of mass. I'll be showing you all the questions. Don't worry about that. Let's suppose you have this question. You have this question. Question says, find the position of center of mass. Find the position of center of mass. Guys, is this clear? Please tell me in the chats with the fire emojis. Is this clear? Is this clear? That's great. Find the position of center of mass. Find the position of center of mass. You have basically 4 masses in this particular question. 2 kg. You have 4 kg present over here. This is 4 kg. This is 8 kg and this is 16 kg. And consider this at origin. Find the position of center of mass with respect to 2 kg or from 2 kg. Consider this at origin. That's why 0, 0. And this is at what distance from origin, sir? 10 meters in xx. 10 in x. Sir, y coordinate is 0. Here, this is 0, 10. Here, y coordinate is 10 and x coordinate is 0. Here, this is 10, 10. Here, both x coordinate is given, y coordinate is given in this particular case. This is the important question which you guys need to understand over here. This is the important question which you guys need to understand over here. Listen carefully, my dear NEET aspirants. See. In this particular case, if you have to find the position of center of mass, you will be simply applying the formula in this case, that is RCOM, that is position of center of mass. It is going to be, that is M1R1 plus M2R2. Okay, how many particles are there? 4. Then we say plus M3R3, then plus M4R4, then whole divided by, I would say M1 plus I would say M2 plus I would say M3 plus I would say m4. These are the four particles, four masses, and this is how you can find. Now the question in this particular case is how to find R1, R2, R3, R4. Simple. I'll tell you. I'll show you. I have told you this previously in the vectors. Right now I'm going to show you this. See guys, when it comes to the value of R1, okay, that is position vector of center of mass. See guys, this is going to clear all the confusions out. What is the x coordinate here? 0. Y coordinate here? 0. I would say its position vector is going to be 0. Means position vector tells you at what distance, at what position the object is with respect to the origin. So if this is at origin itself, so then its position vector will be 0. Then if I say position vector, let's suppose R2 for this mass. For this mass, I'm supposed to write position vector. What is its x coordinate? That is 10. So I'll be mentioning over here 10 I cap. I cap is the unit vector along x-axis. That's why I'm mentioning I cap. Sir, what is the y component? What is the y coordinate? That is 0. So we say plus 0 j cap. So I'll not mention that. Let's talk about this one. In this case, we say y coordinate is given. So I can say R3 over here. It is going to be R3 in this case. It is going to be that is 10 j cap. Because I cap is 0. X coordinate is 0. And when it comes to the R4 position vector, here x component is given, y component is given. So I will be mentioning in this particular case that is 10 I cap plus 10 j cap, my dear NEET aspirants. I believe this is crystalline clear. I believe this is crystalline clear. Okay. Now let's find the position of center of mass. That is RCOM, position of center of mass. M1, R1. What is the value of first mass? What is the value of first mass? That is 2 kg. And what is the value of R1? That is 0. So you will be writing over here that is 2 into I would say 0. Then plus M2, R2. My dear NEET aspirants, I can say value of M2 is 4. R2 is 10 I cap. So I can write over here this will be 4 into 10 I cap. Something like this plus M3. What is the value of M3? What is the value of M3, my dear NEET aspirants? That is 8 and this is 10 j cap. So I'll be writing over here that is 8 into 10 j cap. 8 into 10 j cap. And then my dear NEET aspirants, we say this is 16 into 10 I cap plus 10 j cap. So I can write plus 16 into 10 I cap plus 10 j cap. Something like this. And whole divided by. This is going to be M1 plus M2 plus M3 plus M4. That is 2 plus 4 plus 8 plus 16. This is how we are supposed to write this. Now, my dear NEET aspirants, follow this. This is going to be in this particular case. 4 into 10 is 40 I cap, 80 J cap, 160 I cap, 160 J cap. Okay. So finally, I can write over here after simplifying this, it is going to be that is 200 I cap. Okay. Then plus 240 j cap. Okay. Then I would say divided by 16 plus 8 plus 4 plus 2. It is going to be 30. It is going to be 30. It is going to be 30. And then my dear NEET aspirants, so this is going to be 200 divided by 30 I cap plus 240 divided by 30 j cap. Okay. So something like this. Now guys, 0 and 0 will cancel, 0 and 0 will cancel. Okay. So this is going to be something like this. That is 20 divided by 3 I cap plus 24 divided by 3. So this is going to be 8 j cap. This is the position of center of mass. Now, my dear NEET aspirants, please take a look. This is what we are going to consider the x component, or I would say x coordinate of center of mass, and this is y coordinate of center of mass. So you can simply say XCOM is going to be 20 divided by 3 and y coordinate of center of mass is going to be 8. I believe you got the crystal clear feel of this particular equation. Please write in the chats if this is crystalline clear. Everyone means everyone. If this is crystalline clear, please tell me in the chats with the fire emojis. Everybody. We got the position vector of center of mass. We got the coordinates also. Is that clear, my dear NEET aspirants? I believe everything is crystal clear and sorted. That's great. That's great. Now, guys, let's move on to this particular question. Listen to this question. See this question first and understand the question very carefully. The position vector of three particles. You have got how many particles? Three. Of mass m1 is equal to 3 kg, m2 is equal to 2 kg, m3 is equal to 5 kg. These are the three particles, m1, m2, m3. And their position vectors means r1 is given, r2 is given, and r3 is given. This is r3. Okay. And then it is asking us to find the location of center of mass. We can use, sir, simple RCOM is equal to M1 R1 plus M2 R2 plus M3 R3 upon M1 plus M2 plus M3. Just. But let's make it bit simple. Let's make it bit simple. See, guys, take a look at the options over here. Take a look at the options. Instead of using RCOM, I'll just write over here. I prefer to find its x coordinate only. Sir, why not RCOM? You can use RCOM, but that will make it complicated. Not complicated, so calculations will be lengthy. But if you find x coordinate directly, it will be easy. Okay, let's find x coordinate. Let's find x coordinate. XCOM, XCOM, x coordinate of center of mass. So, guys, x coordinate of center of mass is going to be, that is m1 x1 plus m2 x2 upon, I would say, m1 plus m2. Now, my dear NEET aspirants, m1, what is the value of first mass? M1 is given as 3 kgs. You can see it over here. M1 is given as 3 kgs. M2 is given as 2 kgs and M3 is given as 5 kgs. So this is 3 into. Now, guys, please listen carefully. What is the x coordinate of What is the x coordinate of first object? Sir, that is 1. Y coordinate is 2. Z coordinate is, sorry. X is 1, Y is 1, Z is 1. And what is the x coordinate of first object? This one, 2. What is the x coordinate of this third object? Sir, that is 1. Okay, because this is R1, this is R2, this is R3. So this will be x coordinate, y coordinate, z coordinate, x coordinate, y coordinate, z coordinate, x coordinate, y coordinate, z coordinate. So I can write in this particular case, sir, 3 into, I would say 1 over here. Okay, 3 into 1. Then we say plus, what is the second mass? Second mass is 2 kg and it's x coordinate because we are finding x coordinate only. That will be 2. Then plus, what is the third mass? That is 5. And what is the x coordinate? That is 1. Then I would say m1 plus m2 plus m3. Okay, these are the three particles we have over here. So you need to add plus m3 x3 upon plus m3. Now, my dear NEET aspirants, so this will be m1 is 3 plus 2 plus 5. Now, this x coordinate of center of mass came out to be, follow this, my dear NEET aspirant, this will be 12 divided by 10. So that is going to be 1.2 I cap. Now, this is just a one-liner question if you find the x coordinate. If you use RCOM, it will become complicated. Now, in which of the options you have got x coordinate as 1.2? So directly option first is the answer. Please give me the signal in the chats if this is clear. I need the signal in the chats if this is clear, my dear NEET aspirants. I need the signal in the chats if this is crystal and clear. Everybody, quick. Let me know in the chats if this is crystal and clear. And guys, smash the like button if you have not liked the session, because liking the session is extremely mandatory. And one more important thing, my dear NEET aspirants, let's suppose, sir, what if the option here also it was 1.2 I cap? Then what? Which option is correct? Then you can find the y coordinate. Okay. Then check for y coordinate if y coordinate is matching. So if y coordinate is matching, that option is going to be the correct option. Let's move on to the next question, my dear NEET aspirants. See, what is the position of center of mass from 4 kg in the given arrangement? In the given arrangement, all the masses are present on x-axis. Okay. Just a second. Yes. Take a look. Take a look, guys. What is the position of center of mass? What is the position of center of mass from 4 kg in the given arrangement? From 4 kg in the given arrangement. So don't you see all the masses are present on the x-axis? All the masses are present on x-axis. You can clearly see all the masses are present on x-axis. So shall we prefer finding x coordinate of center of mass? Absolutely, sir. And it says from 4 kg. If it is saying from 4 kg, you need to consider 4 kg at origin. You need to consider 4 kg at origin. That's why 0, 0. This is origin. I believe this is clear. I believe this is clear. And in this particular case, you can directly find x coordinate of center of mass. Why? Because all the masses are present on x-axis. So x coordinate of center of mass in this particular case is going to be, that is m1 x1. Okay. Then m2 x2 upon m3 x3. So this will be m1 is 4 kg and x1 is 0. Then plus m2 in this particular case is 3 kg. Okay. You can consider this as m2. Doesn't matter. Okay. This as m2. Okay. Okay. And this is at what distance? I would say 8 meters. Then plus m3 is 2 kgs. And 2 kg is at what distance? Guys. This is plus 8 from here. Towards right, it is plus. Towards left, it is minus. It is at minus 12 meters. So it is going to be minus 12 meters. Then we say plus m4x4. That is 6 into minus 10. I can write it like this. Sorry. It is not 6 into minus 10. Because you are finding it from the origin. So from here, it is 12. From here, it is 10. 10 plus 12 is 22. 22. So I can say this will be 22. Then upon m1 plus m2 plus m3 plus m4, you can say 6 plus 2 plus 3 plus 4. Okay. So x coordinate of this will come out to be, if you solve this, it will be minus 132 divided by 15. That is minus 8.8 meters. So its center of mass will be from here at minus 8.8 meters. I believe this is clear. I believe this question is also clear. I believe this question is also clear. Okay. Tell me, guys, is this clear? And smash the like button if you have not liked the session yet. Kashif Alam, I would suggest you to solve more questions. Okay. So these questions are sufficient, but try to solve more questions from your end also. At least 50, 60, 70, whatever is possible from your end, then it is good. Then it is fine. Okay, dear. Yeah, minus 22. It is minus 22. Minus 22. Okay. It is obvious. Yes, it is minus 22. Now, my dear NEET aspirants, let's take a look. Two bodies of mass 1 kg and 2 kg are lying on XY plane. Okay, at this is the coordinate. You have two bodies of masses 1 kg and 2 kg are lying in the XY plane at minus 1, 2 and 2, 4 respectively. Find the coordinates of center of mass. You guys are supposed to find the coordinates of center of mass. Guys, in this particular case, it is given. You can clearly say, sir, R1 will be the position vector over here. Sir, what is the position vector of first mass? From this, you can find the position vector. That is minus I cap plus 2j cap. What is R2 position vector? Clearly from coordinates, we can find position vector in this particular case. That is going to be 2I cap plus 4j cap. Now, my dear NEET aspirants, can I say position of center of mass in this case will be how much? That is M1R1. What is the value of M1? That is going to be 1. And R1 is minus I cap plus 2J cap. Then plus M2R2. M2 in this particular case is 2. And R2 in this particular case is going to be 2I cap plus 4J cap. Something like this. Then upon, I would say M1 plus M2. That is 1 plus, I would say, 2. And my dear NEET aspirants, follow this. This will come out to be 3I plus 10J cap divided by 3. So here, here, guys, can you write it like this? 3 divided by 3 is I cap plus 10 divided by 3J cap. What is going to be the x coordinate of center of mass? What is going to be x coordinate of center of mass? That is going to be 1. What is going to be y coordinate of center of mass? That is going to be 10 by 3. I believe this is crystal clear also to all the students out there, all the NEET aspirants out there. Yes. Yes. Is that clear, my dear NEET aspirants? I believe this is crystal clear. Okay, boys and girls. Now let's talk about shift in the center of mass. Shift in the center of mass. Sir, what does shift in the center of mass mean? I'll make you understand. I'll make you understand. Listen carefully. Listen carefully, my dear NEET aspirants. Listen carefully. Let's suppose if I say I have mass M1 over here. Okay, I have mass M1 over here. I have mass M2 over here. Okay, this is mass M1. This is mass M2. And their center of mass will be somewhere around over here. This is center of mass in between the two masses. Let's assume it like that. If you're shifting the two masses from one point to another, let's shift these two masses. Let's shift these two masses. I'm shifting these two masses till here. Is the center of mass also shifting, or center of mass remains here only? Please tell me in the chats. Is the center of mass also shifting, or center of mass remains at the same point? Sir, center of mass will obviously shift. And that is what we call shift in the center of mass. That is what we call shift in the center of mass. If M1 is M2, if M1 and M2 is moving from one point to another, we say center of mass will also move from one point to another. Center of mass will also shift from one point to another. That is what we call shift in the center of mass. Okay. Now, guys, listen carefully. Listen carefully. Sir, if M1 shifts by some amount, some distance, okay, and if M2 shifts by some distance, listen carefully. If M1 shifts by, I would say, delta R1. Let's suppose this is the distance covered by which mass? M1. And M2 shifts by delta R2. This is the shift in the mass 1 and this is the shift in the mass 2, delta R1 and delta R2. If I say, sir, how much will be the position, how much will be the shift in the center of mass? Then shift in the center of mass will be. Listen carefully. So you will be saying, sir, in this particular case, that is delta RCOM. This is shift in the center of mass. This is not the center of mass. How much it has shifted, how much it has moved, what distance it has shifted. So this is going to be, it is going to be simply, that is M1 into delta R1. Simple, bro. Then we say plus M2 into delta R2. Then I would say M1 plus M2. I hope this is crystal clear to each and every single student whosoever is watching this particular session. Guys, tell me in the chats if this is crystal and clear out there. Quick. Is this crystal and clear? So M1 delta R1. Okay. So it is simple. I am saying over here. Let's suppose, guys, you have mass 1 over here. You have mass 2 over here. If you are shifting this mass, these two masses from one point to another, we say in this particular case, we say in this particular case, we say in this particular case, the center of mass will also shift. Is this clear? Is this clear? Is this clear? Is this clear? जिसमें डेरिवेशन चाहिए होता है, डेरिवेशन खाली उसी में कराते हैं. ओके. एंड अगर कोई 12th क्लास का, इफ देयर इज अ स्टूडेंट फ्रॉम 12th क्लास, वी शो द डेरिवेशन ऑफ एवरी सिंगल टॉपिक जो बोर्ड में आएगा. एंड व्हेन इट कम्स टू द नीट और एंट्रेंस क्लासेस, उतना टाइम नहीं होता डिराइव करने के लिए. तो लेकिन जो जो चीजों में इंपॉर्टेंट डेरिवेशन है कि यहां डेरिवेशन करना है, वहां हम करते हैं. आई बिलीव दिस इज क्रिस्टल एंड क्लियर. Now, my dear NEET aspirants, till now we were studying center of mass of different systems. Sorry, center of mass of different point masses. Center of mass of different point masses. My dear NEET aspirants, I want you to understand this very carefully. I want you to understand this very carefully. See, if you have, sir, M1, this is M2. Sir, where is the if the position of this is given R1, position of this is given as R2. Sir, can you find the center of mass? Sir, in just a minute, I'll find the position of center of mass. Sir, RCM is M1 R1 plus M2 R2 upon M1 plus M2. But my dear NEET aspirants, if these discrete masses are not given, if a body is continuous, try to look at this. If the body is continuous, continuous means you have a rod. It is not something you have one mass here, one mass here. No, the mass is present on the entire rod. Mass is present on the entire rod. Here, mass is not fixed at a point. It is mentioned. It is mentioned. In this particular case, mass is not fixed at a point, but it is distributed. So if this is a rod, mass is here also, here also, here also, here also, here also, here, from here to here. So mass is distributed on the entire rod. In this particular case, how can you find the center of mass? Sir, over there you are applying M1 R1, M2 R2, or if you find x coordinate M1 X1, M2 X2, M1 Y1, M2 Y2. Simple. How do you find the position of center of mass in this particular case, in this continuous rod system? How do you find the center of mass of this disk? How do you find the center of mass of the sheet? There is a sheet, like I have a sheet over here. Sir, where is the center of mass of the sheet? If you have a sphere, where is the center of mass of the sphere? How can we find that? That is what we need to find out. That is what we call center of mass of continuous mass system. This is called continuous mass system, in which mass is present at every point. Mass is distributed. It is not present at one single point. See, guys, what is the logic that we use over here? What is the logic that we use over here? Let's suppose this is the body that you have. You need to find the center of mass of this body. This is the body. You have to find the center of mass of this body. Now see, do one thing. Sir, what is the concept that you have told us? That is, if you have two discrete masses, okay, M1, M2, okay, and let's suppose this is origin. You have to find the center of mass with respect to the origin. So from here it is R1 distance, R2 distance, and from here it is R1 distance. You simply say, sir, this mass multiplied by this distance. This mass multiplied by this distance. So M into R, that is moment of mass. So you basically use this particular concept to find the center of mass. How can you find it over here? I can use the same concept here also. Do one thing. Take a small mass. That is dm. And this small mass is infinitely small. This is infinitely small. This small mass is infinitely small. From this, you can consider this as a discrete mass. It is at what distance? It is at what distance? It is at a distance of, this is origin. This is origin. This is origin. It is at a distance of r. This is the position vector. Okay. Then, my dear friends, take one more small mass, that is dm. And this mass is also at a distance of what? Let's suppose this is R2, R1, R2, R3, and so on. Take one more DM mass, find its position vector also. And my dear NEET aspirants, you are breaking this body in infinite number of DM masses. Okay. So I'll write, let's break the body, let's break the body into infinite infinite number of DM masses. Small DM masses, small discrete masses. Then you have to find the position of center of mass. How can you find? Array, sir, now it is simple. Then position of center of mass is going to be, sir, that is mass M1 into R1. M1 is DM and R1 is R. Then plus DM into R, M2 into R2. Then plus DM into R, and so on up to infinity. And then whole divided by, I can simply say, my dear NEET aspirants, in this particular case, this is going to be, that is M1 plus M2. So that is going to be DM plus DM plus DM up to what? Up to infinity. So if you have infinite number of masses, moment of masses, you need to add these. How can you add these? So RCOM in this particular case will be integration of DM into R, because this is how we find. Okay, integration of DM into R, or you can write in this particular case, integration of RDM upon, I would say, integration of DM. This is how we find the position of center of mass in case of a discrete mass system. Please tell me in the chats if you understood the logic behind this. Please tell me in the chats if you understood the logic behind this with the fire emojis, if this is crystalline clear. And do smash the like button, my dear NEET aspirants. Tell me, guys. Okay, that's great. That's great. Now guys, let's talk about understand this very carefully. So this is the position of center of mass. Position. This is not the x coordinate of center of mass. Sir. Now let's suppose we got the position of center of mass in this particular case. Let's suppose that, see. I'll make the new diagram over here. Let's suppose this is the body. And in this particular case, let's suppose this is the center of mass. This is the center of mass. You got its position with respect to the origin, that is R. You got the value of RCOM. This is RCOM. Now we can find its x coordinate. Now we can find its y coordinate. We can find its z coordinate. When it comes to the x coordinate of center of mass, understand this very carefully. It will be simply, guys, integration of xdm upon integration of dm. Array, sir, instead of r you need to put x. And then if you find y coordinate of center of mass of continuous body, this is integration of y dm upon integration of dm. Array, sir, amazing. Then if you say integration of, sir, z coordinate of center of mass, integration of z dm upon integration of dm. This is going to be the position of center of mass. I believe everything is crystal clear to each and every single student. I believe this is crystal clear to each and every single student. Now, guys, listen to me very carefully. Let's talk about center of mass of an arc. What does arc mean? See, guys, let's suppose this is a circle, complete circle, a ring. I have got a ring. This is a ring. Just a second. I have got a ring. Okay. I have got a ring. This is the ring I am having. Okay. Understand this. Now this is a complete ring. If I break this ring in two parts, so upper part, lower part, this is called upper part is semicircular ring, lower part is semicircular ring. If I break this ring in four parts, okay, four parts. So this is what we call chord. This is what we call chord. Okay. So this is semicircular. Okay. Okay. We also call it the segment. We also call it the segment. Now, my dear NEET aspirants, segment means some portion of the ring from here to here. So this is also segment. From here to here, this is also segment. From here to here, this is also segment. Okay. Yes. All of this is considered as segment of the ring. Segment of the ring. Okay. Now, my dear NEET aspirants, when I say in this particular case, if you have to find the center of mass of this arc, this segment, or we also call it the segment of the ring, you directly remember. Here we are not going to derive because that we don't have that much of time to derive this. So I'll directly say in this particular case, my dear NEET aspirants, when it comes to the center of mass of this, I'll write over here y coordinate of center of mass. Sir, y coordinate. Why are you saying on y? Because its center of mass will lie on the y axis only. So if I make over here in this particular case x coordinate and y coordinate, and let's suppose this is 0, 0 origin, this is y axis and this is x axis. So its center of mass will lie here on y axis. So x coordinate, how much we are taking? 0. So I can say it will be simply that is r. R is the radius. As if let's suppose this is the arc from here to here, you are cutting this arc. So this will be a radius, this will be radius. Angle between r and r, this is theta. This is theta. This is theta. Okay. So then we say r, then I would say sine of theta by 2 upon theta by 2. You guys have to directly remember this. You guys have to directly remember this in this particular case. Okay. You guys need to directly remember this in this particular case. Okay. This one. This is the center of mass. This is the center of mass. This is the y coordinate of center of mass of an arc. Okay. And x coordinate is how much? 0, because it is present on the y-axis. The center of mass will be present on y-axis. Okay. Now, my dear NEET aspirants, let's suppose we have a semicircular ring. Consider this as a general formula. This is the general formula. General expression. General expression. Now, in case of semicircular ring, guys, listen carefully, please. We say from this point to this point, this is radius r. From this point to this point, this is radius r. Angle between this r and r, this is theta. Angle between r and r is theta. If I say, sir, what is going to be the value of theta in this case? I would say theta is 180 degree without a shadow of doubt. So if I say what is going to be the position of center of mass over here, center of mass will lie here also on y-axis. So position of center of mass in this particular case will be, that is r sine of theta by 2. We recently studied the general formula. Theta over here is 180 by 2 upon r sine of theta by 2 upon theta by 2. So that is 180 by 2. 180 divided by 2. And instead of 180 by 2, I want you guys to write 180 means if I say theta is equal to 180, it is also pi radians. We can also mention it in pi radians. So better is to write this in pi. So 180 or pi, it is one and the same thing. So it will be pi divided by 2, or we say pi divided by 2. Absolutely, sir. Absolutely, sir. Now, my dear NEET aspirants, what can I say in this particular case? Sine of pi by 2, sine 90 is, I would say 1. Okay, so this will be r upon pi divided by 2 because sine pi by 2 is 1. So now you can take this in the numerator. You can write this 2 in the numerator, 2r divided by pi. So this is the y coordinate of center of mass. And if you ask me what is the x coordinate is going to be 0 in this particular case. I believe this is crystal clear to each and every single student. So we got y coordinate, x coordinate in this particular case is 0. Okay. Is this clear? Tell me in the chats. Quick, 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 quick. In case of a complete ring, what is the value of theta in case of a complete ring? Array, sir, it is theta is 360. That means 2 pi. That means 360 degrees. In case of a complete ring, theta is how much? 360, or we say 2 pi. Now tell me, my dear NEET aspirants, what is going to be the y coordinate of center of mass? Sir, let's talk about YCOM. YCOM is equal to r sine of 2 pi divided by 2 upon, we say theta by 2, that is 2 pi divided by 2. R sine of theta by 2, theta is 2 pi. 2 pi by 2, 2 and 2 will cancel, sine pi. R sine of pi, sine pi is 180. 180 sine 180 is 0. So 0 multiplied by something is 0. So y coordinate is 0. Y coordinate is 0. And what about x coordinate? X coordinate, we already know it is 0. X coordinate is already 0. Now, my dear NEET aspirants, you got x coordinate 0, y coordinate 0. Don't you think that is origin? Array, sir. Absolutely, that is origin. Obviously, for a circle, for this ring, it is at center. That means center. Okay, let's talk about, my dear NEET aspirants, let's talk about center of mass of uniform disk. Okay, let we have uniform. This is semi disk. This is not the complete disk. This is the semi disk, center of mass of the semi disk. Okay, half of the disk, and its mass is m and radius is in this particular case r. Okay, now my dear NEET aspirants, in this particular case, I want you guys to directly remember. What you guys need to remember is y coordinate of center of mass in this particular case is going to be, that is 4r divided by 3 pi. We will not be deriving this, 4r by 3 pi, y coordinate. And this is x-axis, this is y-axis. And when it comes to the x coordinate of center of mass, that will be 0. So its center of mass will lie somewhere around over here. So x coordinate is 0. And then, my dear NEET aspirants, if I talk about center of mass of hollow hemisphere, just a second. Okay, hollow hemisphere. This is what we call hollow hemisphere. Okay, this is hollow hemisphere. And in this particular case, my dear NEET aspirants, when we talk about the hollow hemisphere, listen carefully. This is x-axis and this is y-axis. We say its center of mass will be at, I would say, r by 2. Okay, it will be at r by 2, where r is what we call the radius. R is the radius. And x coordinate in this particular case is 0. So I can say in this particular case, y COM is r by 2. And x COM in this particular case is 0. Y coordinate is r by 2 and x COM in this particular case is 0. Okay. Then, my dear NEET aspirants, center of mass of a solid hemisphere. Solid means which is filled from inside. Hollow means which is hollow from inner side. Like if I wear a cap, so cap is hollow hemisphere. It is hollow from the inner side. But solid means which is filled from the inside. I cannot wear solid hemisphere. That's why it is shown over here. Okay. And in this particular case, guys, center of mass, I would say x coordinate of center of mass is going to be 0. And when I say y coordinate of center of mass, that is going to be 3r divided by 8. 3r divided by 8. Okay. Then we say hollow cone. Okay. Then we say hollow cone. Cone means that cone-shaped structure that people wear on the birthdays. This is the cone. This is x-axis and this is y-axis. This is x-axis and this is y-axis. R is the radius of the cone and h is the height of the cone. H is the height of the cone. This is h. In this particular case, if you ask me for this cone, hollow cone, I would say x coordinate is going to be 0 because it will lie somewhere around over here. Sir, what if lies somewhere around over here? Then x coordinate is not 0. So when it lies on my axis means x coordinate is 0, obviously. Okay. And when I say y coordinate of center of mass, that is going to be h divided by 3. H divided by 3. Okay. Where h is the height of the cone. Where h is the height of the cone. Let's talk about the solid cone, my dear NEET aspirants. Let's talk about the solid cone. When it comes to the solid cone, x coordinate is 0. X coordinate of center of mass is 0. And y coordinate of center of mass is going to be h divided by 4. H divided by 4. Okay. So I believe this is crystal clear to each and every single student. X coordinate is 0 and y coordinate is h divided by 4. X coordinate in this case is 0 and y coordinate is h divided by 4. Okay? Yes. Solid means which is filled from inside, which is not hollow. Then, my dear NEET aspirants, let's move on to an important concept, that is what we call linear mass density. Let's what we call linear mass density. Guys, give me the signal in the chats. Is this crystal clear till over here? Everyone means everyone. Give me the signal in the chats if this is crystal and clear. Tell me, guys, quickly in the chats if this is crystal and clear. Okay. Now, guys, linear mass density. Linear mass density. What does linear mass density actually mean? Linear mass density, what does it actually mean? See, guys. When it comes to the linear mass density, I'll make you understand. Let's suppose we have got 5 apples. Okay. 5 apples. And we have got 1, 2, 3, 4, 5 people. 5 apples and we have got 5 people. I want you guys to distribute these 5 apples and 5 people. Could you please tell me how many apples every single person is going to get? You say, sir, 1. How? You say total apple divided by total number of persons. Okay. So total apple is 5 divided by total person is 5. 5 by 5, that is 1 each. So this, I can ask the same question in a different language. What is that? How many apples unit person will get? Unit person means 1 person. How many apples unit person will get? Unit person is going to get 1 apple. How many apples unit person will get? That is 5 divided by 5, that is 1. Okay. Yes, absolutely. Yes, sir. Now, my dear NEET aspirants, what I can say in this particular case is, when it comes to the linear mass density, let me use the same analogy. If I say, sir, what is the mass of the rod? You say, sir, M. What is the length of the rod? That is L. How much mass is present on L length? You say, sir, M mass is present on L length. Absolutely. M mass is present on L length. If I say, what is the mass present on unit length? What is the mass present on unit length? You say, sir, that is total mass divided by total length. Total length. And that is what we call total mass is m, total length is L. That is m divided by L. And this is what we call lambda. So lambda means how much mass is present on unit length. So lambda tells you how much mass is present on unit length. That is mass per unit length. Like if I say, let's suppose you have a rod, its length is 10 meters and its mass is 10 kgs. If I say, what is the mass present on unit length? That is, what is the mass present on 1 meter, unit meter? You'll be saying, sir, 10 divided by 10, that is 1 kg. So that's what I'm saying. Mass present on the unit length. Who is going to give you that? That is what we call linear mass density. Linear mass density. That is called mass per unit length. Okay. Now, my dear NEET aspirants, if I say one more important point, if I say, if the mass on the rod is not uniformly distributed. If the mass present on the rod is not uniformly distributed means what? If the mass present on the rod is not uniformly distributed, listen to me very carefully, my dear NEET aspirants. Listen to me very carefully, my dear NEET aspirants. If the mass present on the rod is not uniformly distributed, that means if you have a rod over here, okay? If you have a rod over here, we say mass here is more, it is heavier from this side, and mass from this side is less. Mass here is more, something like that. Heavier from one side, less heavier from another side. So mass is not uniformly distributed. In that particular case, what you guys are going to do is, you will be considering a small length, that is DL. On this DL length, we say mass will be constant, that is DM. DM will be constant. Guys, when the mass is uniform on the entire rod, okay, when the mass is uniform on the entire rod, mass M present on L length. So mass on the entire rod is uniform, my dear NEET aspirants. When the mass on the entire rod is uniform, so then you can say M by L. When mass is not uniform, so in that case, you will take a small DL length. So on that DL length, we consider mass as uniform constant. Why, sir, from here to here, mass is changing. It is different. But at one single point, mass is constant. So here, if you have to find mass per unit length, you'll be saying, sir, DM divided by DL. So this you will be applying when mass is not uniform. And this you will be applying, another one you will be applying when mass is uniform. Similarly, surface mass density. Surface mass density. If you have a sheet, what is the mass of the sheet? M. What is the area of the sheet? A. If I say what is the mass present on unit area, I'll say mass present on the unit area. Mass present on the unit area. Now, my dear NEET aspirants, in this particular case, you'll be saying, sir, sigma is equal to total mass divided by total area. That is, total mass is M divided by total area is A. That is what we call sigma. So sigma gives you mass on the unit area. Lambda gives you mass on the unit length. So when you have a rod, in that case, you'll be using lambda. When you have a sheet, in that case, you'll be using sigma. Okay. And my dear NEET aspirants, if I say, if the mass is not uniformly distributed, if the mass is not uniformly distributed on the sheet, in that particular case, what you are going to do is, you'll be saying, sir, lambda is equal to dm divided by dA. Because in that case, you'll be taking the small area. dA. On that dA, mass is going to be constant, dm. So you can use dm by dA. Similarly, volume mass density. if you have got a sphere, solid sphere. Sir, what is the mass present in the unit volume? Mass present in the unit volume. Mass present in the unit volume. How do you find mass present in the unit volume? Sir, that is going to be total mass divided by total volume. It is going to be rho. It is going to be rho. Rho means volume mass density or mass per unit volume. Then, my dear NEET aspirants, we say if the mass is not uniformly distributed in the sphere, somewhere it is more, somewhere it is heavier, somewhere it is less. So I can say if the mass present inside the sphere is not uniform, then rho will be dm divided by dv. Guys, tell me, is this clear? Tell me quickly in the chats, is this clear? Everybody out there. So if you have to find the mass in the unit volume, you'll be simply using rho. Okay. If you have to find the mass present in the unit area, you'll be using sigma. If you have to find the mass present in the unit length, then you'll be using lambda. Then you'll be using lambda. I believe everything is crystal and clear till over here. I believe everything is crystal and clear till over here. Okay. Yes. Yes. Now, guys, let's talk about center of mass of a rod. Let's talk about center of mass of a rod. Listen carefully. I'm going to tell you, I'm going to show you the approach in this particular case. Center of mass of the rod of mass m, length L, it will be at the center, that is at L by 2 distance. Let me prove it. Let me prove it. And in this particular case, lambda is constant. Lambda is constant means mass present at every point is same. Whatever is the mass here, same 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 is the mass here. Okay. That means constant lambda. Now, guys, in this particular case, if you have to find the position of center of mass, consider a small element dm of dx width. So then you can say lambda is equal to dm divided by dx. From here, you can say value of dm is equal to lambda dx. Yes, absolutely. Now, if you have to find the position of center of mass in a continuous body, I have told you, in case of a continuous mass system, how do you find the position of center of mass? That is XCOM. Guys, wait. This rod is present on the x-axis. Don't you think we should consider XCOM will find its x coordinate of center of mass? Yes. So that is integration of dm into x upon integration of dm. This is how we find the position of center of mass in case of a continuous mass system. In integration of dm into x, integration of dm, that is lambda dx into x. I'll write x and x first. So this is x integration of dm. Instead of dm, I can write lambda dx divided by integration of dm. So lambda dx is equal to. Now, guys, lambda is constant. Lambda is constant in this particular case given. So take this lambda out. So integration of x, that is going to be x square by 2 upon integration lambda integration of dx, that is going to be x. Integration of dx is x. Okay. Now, guys, from where to where you need to integrate in this particular case, because this point is important. So basically, here it is 0, length is L, from 0 to L. Because you have to consider all the elements which are from 0 to up to L. From 0 to L. So this will be from 0, this is L. 0 to L, 0 to L. Now, guys, what I can say, this is lambda. In this x, you need to put first the upper limit, because this is 0 to L, 0 to L. So lambda and lambda will be cancelled. Put this upper limit that, just a second. So put the upper limit, that is L square divided by 2 minus 0. Lower limit I don't need to mention. Upon, in this x you need to put upper limit L minus 0, that is L itself. Okay. Okay. Yes. Now this is going to be, this L and square will be cancelled, so it is L by 2. So center of mass, see, this is a simple integration I am doing, boys and girls. Center of mass of the rod is exactly at L by 2 if the lambda is constant at half of the distance. If the lambda is constant. Sir, what if lambda is not constant? What if center of mass of a variable mass system? Means lambda is not constant, means, my dear friends, here mass is more, here mass is less, less, more, less, more, less, something like this. This point is, this is very important. This is very important for your NEET as well as GE. Okay. And let's suppose, my dear friends, in this particular case, we say lambda is proportional to x. Lambda is proportional to x means as you move in the x direction, let's suppose value of here is x. Here it is 1, 2, 3. As x increases, we say lambda also increases. Lambda increases means mass per unit length increases. Like, sir, here value of x is less. So value of mass at this point is less. Sir, value of here x is more. Mass will be more because lambda will be more. So what is lambda? Mass present on the unit length. If I say lambda here is more, means mass on this unit length is more. If I say mass here is less, mass on this unit length is less. So if I say lambda is proportional to x, so if x increases, lambda increases, mass increases. I believe this is clear, my dear NEET aspirants. And in this particular case, see guys, if lambda is proportional to x, we say lambda is equal to k times of x, replacing the proportionality with a constant. Yes. Now let's find center of mass here. Consider a small element, that is dm, its width is dx. Okay, dm and its width is dx. Now, my dear NEET aspirants, we can say lambda is equal to dm divided by dx. So dm will be equals to, I can say lambda dx. So dm in this particular case will be, instead of lambda, I can write k times of x, then I'll write dx. And my dear NEET aspirants, you have to find x coordinate of center of mass. Why? Because the rod lies on the x-axis only. So can I say it will be integration of x dm upon integration of dm? Absolutely, sir. 100%, sir. Now it is going to be integration of, this is x and then dm. Instead of dm, I can write k times of x, then dx upon integration of dm. I can write k times of x, then we say dx. And you have to integrate the rod from where to where? From 0 to L. From 0 to L. Because all the elements will be covered from 0 to L. Now, take this k constant, k out. K is out, k is constant. K is out, it will be cancelled. So k is out, integration of, guys, x into x becomes x square. Then we say dx from 0 to L. Upon, take this k out, integration of x dx from 0 to L. From 0 to L. Now guys, k and k will be cancelled. What is the integration of x square? That is going to be x cube divided by 3 from 0 to L. Upon, what is the integration of x? That is x square divided by 2. That is from 0 to L. Okay. Then put the upper limit minus lower limit. Guys, first you need to put L instead of this x. So it is going to be L cube divided by 3 upon. Now in this x you need to pull L, that is L square divided by 2. Now L square and cube will be cancelled. So it will come out to be L divided by 3 upon 1 by 2. Take this 2 in the numerator. So x coordinate of center of mass will come out to be, that is 2L divided by 3. 2L divided by 3 means 0. 2 by 3 means 0.6L. And my dear NEET aspirants, L divided by 2 means 0.5L. So listen carefully. I have told you two cases. If lambda is constant, mass is present at every single point is same, then center of mass will be exactly at center L by 2, 0.5 L. If lambda is proportional to x, this will be given in the question. What is the relation between lambda and x? Then in that case, center of mass will be at 0.6 L. If this is L, this is 0.5 L, this will be 0.6 L. Please tell me in the chats if this is clear, because this was important. This was important. Come on, guys. Quick. With the fire emojis. If you are not like the session yet, please do like the session as soon as possible. Because liking the session means marking the attendance, and marking the attendance is mandatory. Directly, directly, you guys can remember if lambda is constant. See. On this slide, I have mentioned if the value of lambda is constant, means mass present on every on unit length is constant. At every point, it is same. Center of mass will be at L by 2, 0.5 L. If lambda is proportional to x, center of mass will shift from 0.5 to 0.6. If lambda is proportional to x square, directly remember, method is same which I have told you. Center of mass will be at 0.75 L. If lambda is proportional to x cube, then center of mass will be at 0.85 L. Please do remember this directly. Please do remember this directly. The question is given, the question given over here. Take a look. The density of a thin rod of length L varies with distance. Density is not constant for a rod, it varies with distance. Density is not constant, it varies with distance. Okay. Okay, yes. Let's suppose this is a rod and its density is not constant. Its relation is given over here. Lambda is equal to lambda naught x square divided by L square. This is given. Can I say in this particular case, my dear NEET aspirants, if you clearly see over here, you don't need to solve the question, bro. Lambda is proportional to x square. When lambda is proportional to x square, what will be the position of center of mass? What will be the position of center of mass? 0.5 L. 0.575 L. 0.75 L. So I can say directly XCOM is going to be 0.75 L without even solving the question. Without even solving the question. Now take a look. Two identical rods of mass M and length L along X and Y. You have got two identical rods of mass M and length L. Find the location of center of mass like this, like this. You have got two identical rods. Okay, this one and this one. You have to find the location of their center of mass. Guys, if you individually say, sir, this rod, lambda is constant in this particular case, lambda is constant. This will have center of mass at L by 2, 0.5 L. Here also L by 2. You have to find the location of center of mass. Guys, see what I can write over here, RCOM. It is going to be that is M1R1 plus M2R2 then upon M1 plus M2. Now you have to write the coordinates, you have to write R1. So what is the, guys, for this rod, where is the center of mass? So you can assume the mass of the rod here. Okay, you can assume the mass of the rod here. See the question. Now, you can assume the mass of the rod exactly at this point, that is L by 2. You can assume mass of this rod at L by 2 here, at L by 2 here. Now, if you write R1, what is its x coordinate? That is 0, comma, sorry. Its x coordinate is L by 2 and y coordinate is 0. Here, its x coordinate is 0 and y coordinate is L by 2. So I can write L by 2 I cap and position vector R2, I can write L by 2 j cap. Arey, sir, done question. So M1, what is the mass of the rod 1? That is M. R1 in this particular case is L by 2 I cap plus M. R2 is given as L by 2 j cap upon M plus M is 2M. This is position of center of mass. Make sure you write this in the vector form, my dear NEET aspirants. Don't make the mistake. Don't directly write M into L by 2 plus M into L by 2. No. This has a different position. This has a different position. So M and M will be cancelled. So 2 into 2 becomes 4. L by 4 I cap plus L by 4 j cap. So when I say x coordinate over here, x coordinate is L by 4. L by 4. And y coordinate of center of mass is also L by 4. I believe everything is crystalline clear till over here. Find the location of center of mass. Find the location of center of mass. In this particular case, this is L and M. Find the location of center of mass. Take a look at the question. This has length L, mass M. This has length 2M and this has mass 2M and length 2L. Okay. Now guys, instead of these two masses, can you assume their center of mass? Obviously, sir. This is the logic that we use. So center of mass will be over here. This is COM. And it is at L by 2 I cap. Okay. And my dear NEET aspirants, this is at L by 2 J cap. And this is COM. And since it is 2L, okay. Since it is 2L, so I cannot say this is L by 2, this will be L. What is half of 2L? That is L, LJ cap. Now, if I have to write the position of center of mass, RCOM, what is that going to be? M1 R1, that is M1 is M. What is the value of R1? That is L by 2 I cap. Then plus M2. M2 is 2M because mass of this rod is how much? That is 2M. Okay. And then we say L J cap. Something like this. Divided by total mass is 2M plus M, that is 3M. So what I can say, this M and M will be cancelled. So this will be L by 2 I cap plus 2L J cap divided by 3. Now you can multiply this 3 over here, by the way. So RCOM in this particular case will be 3 into 2 is 6. So L by 6 I cap plus 2 divided by 3 L J cap. Okay, its x coordinate will be L by 6, y coordinate will be 2L by 3. I believe this is clear. I believe this is clear. Let's move on to this question. Find the location of center of mass. This has mass M, length 2L. This has mass M, length L. Okay, guys, center of mass of this rod will be at L by 2. Center of mass of this will be at L. This is J cap, this is I cap. So RCOM in this particular case will be M1 R1. M1 is M. R1 in this particular case is L by 2 I cap plus M2 is M and R2 in this particular case is going to be LJ cap. Then M plus M is 2M. So what I can say in this particular case, this M and this M will be cancelled. So RCOM, it is going to be L by 2I cap plus LJ cap divided by 2. So this is going to be 2 into 2 is 4, L by 4I cap plus L by 2J cap. I believe this is clear, huh? Find the location of center of mass. This is good. This one is good. See? Find the location of center of mass. This point, this point, this is the center of mass. Consider this as origin because we always measure from the origin only. So this will be L by 2I cap, its center of mass. Its center of mass will be here. It is L by 2I cap plus L by 2J cap. L by 2I cap plus L by 2J cap. Its center of mass will be here. Okay. So it is going to be, wait. I made a mistake. Its x coordinate is 0. So it will be L by 2. It will be L by 2 J cap only because total length is L. Now guys, see this rod. This has length L. If this is y-axis, this is x-axis. If you check x coordinate of this center of mass, that is L by 2. So this will be also L by 2. So x coordinate is L by 2. And if you check y coordinate is L. L. See, this length in vertical direction is L. Length in horizontal direction is L by 2. So y coordinate is L. X coordinate is L by 2. So you can write over here L divided by 2I cap plus LJ cap. I hope there is no confusion in this one. See, when it comes to this rod, it will be at L by 2 I cap because it is along X only. When it comes to this rod, it is at L by 2 J cap because it is along Y only. When it comes to this, how far is it in the X direction? L by 2. How high is it in the Y direction? That is L. That's why L by 2 I cap, L J cap. Now, if you have to find the center of mass of this entire system, center of mass of the entire system, what will you write? RCOM. That is M1 R1. M1 is this. R1 is L by 2 I cap. M2 is this. R2 is L by 2 J cap. M3 is this. R3 is this. So you can say in this particular case, it will be M into L by 2 I cap plus M into L by 2 J cap plus M into L by 2 I cap plus LJ cap. Array, sir. Then M1 plus M2 plus M3, it is going to be 3M. It is going to be 3M. Then if you say RCOM, okay. Now guys, M, and M will be cancelled. L by 2 I cap, L by 2 J cap, L by 2 I cap. Now guys, solve from the upper side. See, L by 2 I cap plus L by 2 I cap. This is going to be 2 times of L by 2 I cap plus no. In the first rod, we cannot say because it has y coordinate 0. This is x axis, this is y axis. This center of mass has x coordinate also, y coordinate also. But this has only x coordinate, this has only y coordinate. Okay. Now L by 2 J cap plus LJ cap. See, add these two. L by 2J plus LJ. That is going to be 3L by 2J. Divided by 3. Now what can you cancel here? This 2 and 2. So this will become L divided by 3I cap then plus 3L by 2 J cap. This is RCOM. Okay. And whole divided by 3 also, na? So this 3 and this 3 you can cancel basically. So this will become upon 3. This 3 and 3 will cancel. So I'll write in one more step. L divided by 3I cap plus L divided by 2J cap. This is RCOM. Guys, tell me, is this clear? Everybody out there? This is the entire question. Is this clear? Now, let's first come on to the velocity of center of mass. Later, we'll see that concept. Let's first come on to the velocity of center of mass. What does velocity of center of mass actually mean? Listen to me very carefully. Listen to me very carefully. See, guys. Let's suppose you have two masses over here. You have M1, okay? And this mass is moving with the velocity V1. You have M2, this mass is moving with the velocity V2. How many masses you have? Two. M1 and M2. Both are moving with this with some velocity. Now, obviously, they will have center of mass, na? So, center of mass will also have some velocity. Yes. What is going to be the velocity of center of mass? That is the question. Because if two masses are in motion, if you shift two masses, center of mass will shift. If two masses will have some velocity, center of mass will have some velocity. And if I say what is the velocity of center of mass, it is simply going to be, I would say M1 V1, mass of first, velocity of first, plus M2 V2, mass of second, velocity of second, upon M1 plus M2. Array, it is simple. Yes, it is simple. Absolutely. It is simple. It is simple. Okay. Yes. This is the velocity of center of mass. This is the velocity of center of mass. M1 V1 plus M2 V2. Like this is the question over here. Find the velocity of center of mass. This is M1, this is V1. How can you say, sir, velocity of center of mass in this particular case will be? Guys, see. M1 V1. And make sure you write this in the vector form. Because velocity can have different directions, na? So find the velocity of center of mass is M1 V1 plus M2 V2 upon M1 plus M2. Now, what can you write over here? M1 V1. So M1 is M. And what is the value of V1? V1 is 2. Is it along X or Y? It is along X. So I'll write 2I cap. Okay. Then plus M2 is also M. and it has got the velocity of 2 meter per second along y direction. So along y we mention j cap, because j cap gives you the direction of velocity, direction of a vector along y. So this is going to be 2, and then we say j cap. Then we say 2m. m1 plus m is 2m. Now, my dear NEET aspirants, what I can say over here, m, and m will be cancelled. So what I can write in this particular case, this 2, and 2 will be cancelled. So this will come out to be I cap plus j cap. This is the velocity of center of mass. This is the velocity of center of mass, I cap plus j cap. Even you can find the magnitude of this also. Velocity of center of mass, its magnitude. How do you find the magnitude of a vector? What is the x component here? 1. What is the y component here? 1. So 1 square plus 1 square. So that is going to be root 2 meter per second. This is the velocity of center of mass. Absolutely, sir. Absolutely, sir. Okay. Yes. Then acceleration of center of mass. See guys, if you have two masses, acceleration of first is a1, acceleration of second is a2. Sir, what? This is the center of mass. What is the acceleration of center of mass? That is the question. When it comes to the acceleration of center of mass, you'll simply say ACOM. It is going to be, that is mass of first, acceleration of first, plus mass of second, acceleration of second. Then we say upon, we say m1 plus m2, mass of first, acceleration of. Okay. This one. I believe this is also crystal clear to each and every single student. Now we can write it like this also, guys. Have you ever heard as we say force is equal to mass into acceleration? So can I not write this mass into acceleration is what? Force F1, and this is force F2. So I can write the same statement over here, acceleration of center of mass. It is going to be, that is F1 vector plus F2 vector, because sometimes force may be given and they ask you to find the acceleration of center of mass. Then we say m1 plus m2. I believe this is crystal clear to each and every single student over there. Okay, yes, this is the acceleration of center of mass. Let's take a look at the question that is given on the screen. See, 3 particles of mass 1 kg, 2 kg and 3 kg. You have got 3 particles of mass what? 1, 2 and 3 are subjected to forces. Forces are acting on these masses. This is the force on first mass. This is the force on second mass. And this is the force on third mass respectively. Find the magnitude of the acceleration of the system. We are supposed to find magnitude of the acceleration of the system. Here force is given. Force on 3 masses are given. And we have to find acceleration. Which formula you will prefer? You will prefer this formula. Second one. So I can simply say in this particular case, guys, see, acceleration of center of mass, it is going to be force F1 plus force F2 plus force F3 upon m1 plus m2 plus m3. Okay. Now, guys, how can I write in this particular case F1 plus F2 plus F3? Simply, these are the 3 vectors. Okay. So this, and this. So this is F1 plus F2 plus F3. You'll be adding I cap with this I cap and with this I cap. J cap with this J cap plus this J cap. Then K cap with this K cap plus this K cap. I with I, J with J, K with K. Now tell me, what can I write? 3i minus I. 3i minus I is 2i plus I. is again 3i. So, or plus I minus I plus 3i. So this is going to be 3i gap. Then minus 2j plus 2j. Then plus j. This and this will cancel. This will add. So it will come out to be plus j. Then plus this plus 2k. This is plus 2k by the way. Okay. This plus 2k minus k is k. K plus k. This is plus 2k. This is minus k. Plus 2k minus k is k. That plus k, this plus k. Okay, okay. This plus 2k minus k is k. That k plus this k will be 2k. Oh, I hope you are able to do addition and subtraction of two vectors upon m1 plus m2 plus m3. 1 plus 2 plus 3. That is 3 plus 2 is 5 plus 1 is 6. So I can say 6. So this came out to be this one. Okay. Now guys, this is the vector form. In the scalar form, you can find the magnitude of this. So under root of 3 square plus 1 square plus 2 square divided by 6. So this is 9 plus 1 is 10. 10 plus 4 is 14. Root 14 divided by 6. Okay. This is meter per second square. This came out to be the value of acceleration of center of mass. Guys, is this clear? Is this clear? So you have got two particles over here in this question. This is mass m1, this is mass m2. A1, this is A2. Can you find the acceleration of center of mass? Guys, in this particular case, mass m1 is 1 kg. Mass m2 is 3 kg. Okay. And acceleration of first is I minus 2j plus 5k. Acceleration of second is minus 2i plus 4 by 3j minus k. You have to tell me, find the acceleration of center of mass. Can you find this from your end? m1 a1 plus m2 a2 plus m3 a3. This I am giving you as homework. This you guys will be doing from your end. Okay, this one. This is important. This is important. This is important. See, this question we have solved in Newton's laws of motion. This is the m1 mass. It is attached to m2 mass. Guys, tell me in the chats if this is clear till over here. Tell me in the chats, is this clear to till over here? Tell me. Okay, now guys, see. In the Newton's laws of motion, we have studied if you have two blocks, M1 and M2, they are connected by means of a string through pulley. You can find acceleration of the blocks. You can find acceleration of the blocks. Okay. See, guys, I have told you, acceleration, as we know. How do we find acceleration of the blocks? Net pulling force by net mass. We don't have to go there. Acceleration of each block. As we know, acceleration of first block, acceleration of second block. This is simply going to be, that is m2 minus m1 into g upon m1 plus m2. if somebody asks you from now onwards what is the acceleration of each block, you say both blocks are connected by means of the same string, they have got the same acceleration, m2 minus m1 into g upon m1 plus m2. Okay, as simple as that. G is the acceleration due to gravity. Now if I say, now remember this, now remember when it comes to the acceleration of center of mass, it is simply going to be, I want you guys to understand, my dear NEET aspirants, in this particular case, this is a special case, that is going to be m2 minus m1 whole square upon, you just write it like this, m2 minus m1 upon m1 plus m2, its whole square into, I would say, g. Its whole square into, I would say, g. So this is, my dear NEET aspirants, in this particular case, acceleration of their center of mass, because these two masses also have the center of mass. This is the acceleration of their center of mass, and this is their own individual acceleration. This is their own. This comes after the derivation only, but I want you to directly remember. If you have a pulley system, something like this, these are the accelerations of their individual masses. This is the acceleration of their center of mass. If the system is something like this, understand this very carefully. We say here, acceleration of each block. Okay. This is going to be A1 is equal to A2 is equal to. Okay. Both the blocks will have the acceleration of, that is M2 into G upon, I would say M1 plus, I would say M2. This is the acceleration of each block, because here net pulling force in this particular case will be this only. Okay. Okay. Yes, absolutely, sir. Absolutely, sir. Without a shadow of doubt. Without a shadow of doubt. Okay. Yes. Now, if I say acceleration of the center of mass, now acceleration of the center of mass, their acceleration of center of mass. So, my dear NEET aspirants, I want you to remember this directly. So, center of mass will have the acceleration, okay, is equal to, that is m2 into g upon, I would say m1 plus m2 whole square. Then I would say m1 I cap minus, I would say m2 j cap. Please do remember these two expressions, okay, because these are important in this particular case. Okay, just these two expressions you guys need to remember. Their individual acceleration, and their individual acceleration and acceleration of their center of mass. Is this clear, guys? Tell me in the chats, everybody out there. Okay. Okay, guys, we'll take a break for lunch. Okay, then we'll continue. Then we'll finish this chapter. Okay. So, guys, let's do one thing. Let's take a break. So, break till it is 2:05. That is 2:40 till 2:40, because that is 35 minutes of break. lunch break. Okay. See you guys at 2:40. Get done with your lunch, then we'll continue. So, guys, let's get back to business. Let's get back to business. Okay. Yes. Now, guys, we have conservation of momentum. Conservation of momentum. Let's discuss this particular concept. Okay. Let's discuss this particular concept, that is conservation of momentum. Okay. Now, my dear NEET aspirants, in this particular case, I want you to understand one thing. I want you to understand one thing. What is that? See, I'll write over here. Let's suppose for an object, understand this, guys, very carefully. For an object, let's suppose you have mass m over here. You have mass m over here. If I say net external force is 0, net external force acting on this object is 0. What does that mean? Net external force may be acting, but net external force in this case is 0. We can say, sir, this F is equal to dp divided by dt according to the Newton's second law. Change in momentum with respect to time is equal to force. If net external force is 0, we can say change in momentum will be 0. Because if you keep this as 0, 0 multiplied by something is 0. So change in momentum in that case is going to be 0. Okay. So means change in momentum is 0. We have discussed momentum previously. So if change in momentum is 0, we can say final momentum is going to be initial momentum. Okay. Okay. What does that mean? That means momentum is conserved. That means momentum is conserved. Conservation of momentum simply means when the initial momentum of the system is equal to the final momentum, then we say momentum is conserved. Okay. Yes. So this is for an object. Let's suppose for a system of objects, let's suppose you have two masses m1 and you have mass m2. These are the two masses that you are having over here. These are the two masses that you are having over here. Okay. This m1 and this m2. And this is the system right now that I am considering over here. This is the system. This is the system. System means in which you have more than one body. That is the system. This is the system. And in this particular case, my dear NEET aspirants, if I say here, if net external force is equal to 0 on the system, you have two masses. Consider these two as the system. If net external force on system is 0, then we say F is equal to dp divided by dt. In this particular case, my dear friends, you consider momentum of what? Center of mass. Like in this case, this was an object. This was an object. Here you simply said, sir, F is equal to dp by dt. So momentum of what? Momentum of the object. But if you have a system of two objects, here, when you say F is equal to dp by dt, you are writing momentum of center of mass of the two objects. Okay? Yes. So I can say, if we take here center of mass, so I can say in this particular case, this momentum of center of mass, change in momentum of center of mass is 0. Means momentum of center of mass is conserved. Momentum of center of mass is conserved. Okay. 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 So basically, what I'm trying to say is that when you define conservation of momentum for an object, for one object, you simply write dp by dt, momentum of that object. But when you have system of two objects, if you apply dp by dt here, dp means change in momentum. This p you write for momentum, for center of mass. It is not the momentum of this, not the momentum of this. It is momentum of their center of mass. So momentum of the center of mass is conserved in this particular case. I believe this point is crystal clear to each and every single student. Then, my dear NEET aspirants, let's take a look when bomb explodes. Explosion of bomb. This is the famous example that we need to understand over here. Explosion of the bomb. Okay, this is the example This is the example for the conservation of momentum, in which momentum remains conserved, in which momentum remains conserved. Let's suppose, my dear NEET aspirants, there is a bomb. This is a bomb. It has mass m. Before we say explosion, before explosion, this bomb is at rest. Could you please tell me what is the momentum of this bomb before explosion? You say momentum of this bomb before explosion is initial momentum, that is mass into initial velocity. Okay. And initially, if it is at rest, so what is the initial momentum? That is going to be zero. Yes, because initial velocity is zero. So, my dear NEET aspirants, in this particular case, we say here net external force is zero. Here net external force is zero. Net external force on the bomb is zero. When bomb explodes, is it somebody who comes and pushes the bomb from the outside? No. Bomb explodes because of the internal forces. Reactions happen inside the bomb. Because of those forces, bomb explodes. So that's why I am mentioning over here net external force on the bomb is zero. So if net external force on the bomb is zero, we say momentum remains conserved. So whatever is the initial momentum must be equal to final momentum. Whatever is the initial momentum must be equal to final momentum. After explosion. After explosion. When bomb explodes, let's suppose bomb is exploding two different parts, two fragments. First, second. Mass of this segment is m1, velocity is v1. It is going in this direction. Mass of this segment is m2 and its velocity is v2. It is going towards the right. Okay. So can I not say in this particular case, my dear NEET aspirants, what is the final momentum? Final momentum after the explosion is momentum of this plus momentum of this. How do we write momentum of a body? m1 v1, and I'll write minus m1 v1. Why? Because its velocity is left. If the velocity is in the left direction, velocity is taken as negative. Plus momentum of the second mass m2 v2. But since my dear NEET aspirants, you recently studied that net external force in case of explosion of the bomb is zero. So initial momentum has to be final momentum. So what is initial momentum? Zero. So final must be also how much? Zero. So we say final momentum is zero minus m1 v1 plus m2 v2. If you take it over here, I can say m1 v1 will be equals to m2 v2. It is obvious. If the momentum of this fragment is exactly equal to momentum of this fragment, then only it will be cancelled and net momentum will come out to be zero. Then only it will be cancelled and net momentum will be zero. Okay, so this momentum is cancelling with this momentum. So net momentum of the system remains zero once again. Okay. Yes, absolutely clear, sir. Now, guys, let me just add one more page over here because I need to tell you something which is important. I need to tell you something which is important. See, guys, what is important? I'll make you understand. Just a second. Give me a second over here. Okay. Okay. Just a second. Let me erase this. Just a second. Just a second. Okay. Take a look, my dear NEET aspirants. Take a look, my dear NEET aspirants. See. So we say in case of explosion of the bomb, initial momentum is zero, final momentum has to be zero. So momentum of this fragment must be equal to momentum of this fragment. Cool, absolutely cool. Now, my dear NEET aspirants, take a look. Can I say in this particular case, when it comes to the kinetic energy finally, listen to me very carefully. Okay, let's first talk about kinetic energy initially. Kinetic energy initially. What is the value of kinetic energy? 1 by 2 mvi square. Initial velocity is zero. So kinetic energy initial will come out to be zero. Absolutely, sir, without a shadow of doubt. And when I say finally, what is the kinetic energy finally? You say, sir, kinetic energy finally is going to be 1 by 2 m v1 m1 v1 square plus 1 by 2 m m2 v2 square. That means kinetic energy of this, kinetic energy of this, and kinetic energy of this. Sir, shall we not consider its velocity here negative? This v1 as negative? No, because when it comes to the kinetic energy, this velocity, this is not velocity, this is speed. So here, this v is actually what? It is speed. That's why I'm considering this as positive. Okay. Yes. So I can say kinetic energy final is not equal to zero. But when it comes to the momentum, momentum is zero. So my dear NEET aspirants, what I'm trying to say in this particular case, important point is if net external force is zero, we say momentum is conserved. Momentum is conserved. Okay. So kinetic energy is equal to P square divided by 2m. P square divided by 2m. Okay. This is important point. Take a look what I'm trying to say. If external force is zero, momentum is conserved. This is the equation of kinetic energy in terms of momentum that we have derived in the last class. So kinetic energy is P square by 2m. Now, if momentum is conserved, mass is same, we say kinetic energy is also constant. But, sir, in the above equation, kinetic energy is not conserved. So this expression is valid for single object only. This is valid for single object only. Not for the system. Not for the system. For the system, it is not valid. Why? Because for the system, I have proved that kinetic energy final is not equal to zero. Kinetic energy initial is zero. It is not conserved. But for one mass, for a single object only, we say if external force is zero, momentum is conserved. Then you write this equation. If this is constant, kinetic energy is constant. Please tell me in the chats if this is clear. This is very important point. Tell me in the chats. Tell me, guys, if this is clear. Tell me. Okay. Let's move on to the questions. Take a look, guys. When bomb explodes, okay, okay, this is done. Which of the following cases is possible? In the explosion of bomb, we say initial momentum must be zero. In the explosion of bomb, guys, initial momentum is zero because initially it is at rest. So final momentum also has to be zero. But in this case, let's check if it is zero or not. You say this is m, this is m, this is m. If this is going with velocity v, we say this momentum will be cancelled with this momentum because its momentum is upward, its momentum is downward. So here, when it comes to final momentum, it is not equal to zero. What is final momentum? It is m into v. But initial momentum is zero, so final has to be zero. So this is not possible. This is not possible. Why is this not possible? Because in this particular case, final momentum is not the same as initial momentum. Momentum is not conserved. That's why. Let's talk about this one. When this bomb explodes, initial momentum is zero. What about final momentum? Final momentum also has to be zero. Let's suppose this is m, this mass m, this mass m, velocity v, velocity v, velocity v. Now this momentum will be cancelled with this momentum, because momentum of this is forward, momentum of this is backward, cancelled. So here, this is the net momentum along y. So we say p final is not equal to zero. Not possible. Not possible. Okay, not possible. Then, my dear NEET aspirants, if you take a look over here, this is mass m. Okay, it explodes. It explodes into three different fragments. Understand this very carefully. So, what is the initial momentum, guys? Zero. Final has to be how much? Zero. Guys, see, momentum of this is mv, this is mv, this is m, this is v. Understand this very carefully. If you check this momentum is along x, if you check this momentum is along y, don't you think their resultant would be something like this? Yes, and their resultant would be something like this. Okay. Don't write MB, 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 because then it will create confusion. Okay. Write it simply, sir, this is momentum along this. This is momentum along this P1, this is P2, and this is P3. Something like this. Sound is not clear, huh? Sound is not clear. Okay, is it fine now? Is it fine now? Please tell me in the chats. Is the sound clear? Is the sound clear? So you can say momentum of this and this. It is going to be, sir, this P net. These two have the net momentum, something like this. Now this P3 is cancelled with this. So P3 is cancelled with P net. So final momentum in this case came out to be zero. Final momentum came out to be. Okay. So in this particular case, let's suppose this M1 V1, M2 V2, M3 V3. These two will get cancelled. This is M1 V1, M2 V2, M3 V3. Generalize it. Generalize it. So that case is possible in which momentum is conserved. That case is not possible in which not momentum is conserved. I believe everything is crystal and clear. Okay. The question says, take a look. A particle at rest explodes into two masses M1 and M2. A particle at rest explodes in two parts into M1 and M2. Find the ratio of their kinetic energies. We are supposed to find ratio of their kinetic energies. Guys, see, we can say in this particular case, when this bomb explodes, what is the initial momentum? Zero. Okay. We say in this particular case, net external force is zero, so P must remain conserved. So we say final momentum also has to be equal to zero. Okay, final momentum also has to be equal to zero. So can I say if momentum is conserved, guys, listen to me very carefully. We say kinetic energy is equal to P square divided by 2m. Momentum is no doubt conserved. Momentum is no doubt conserved, my dear NEET aspirants. So if momentum is conserved, we say kinetic energy is inversely proportional to mass. So whatever is constant in the equation, you need to throw that out. So kinetic energy is inversely proportional to mass. So the one which has got more mass has less kinetic energy. So what I can say, kinetic energy of second divided by kinetic energy of first is equal to m2 divided by m1. Okay. Kinetic energy of first divided by kinetic energy of second, or kinetic, okay, sorry, kinetic energy of first divided by kinetic energy of second. It will be m2 by m1 because the relation is inverse. I hope this is what we were supposed to calculate in this particular case. Then you have the gun bullet system. Okay, then you have the gun bullet system. Then you have the gun bullet system. So conservation of momentum in case of gun bullet system. Okay, let's take a look at this. Let's take a look at this. Okay. Now, my dear NEET aspirants, I want you to understand this very carefully. I want you to understand this very carefully. See, guys. See, guys. When it comes to the gun bullet system, you have a gun over here. This is the gun that you have. Okay. This is the gun that you have. Okay. This is the gun that you have. When bullet is fired from the gun, guys, initially before firing the bullet, this is also the example of conservation of momentum. Before firing the bullet, we say bullet as well as gun is at rest. So we say initial momentum in this particular case is zero. Okay. Now, my dear NEET aspirants, we say external force on the gun bullet system is zero. Because whatever happens inside the gun. When bullet comes out of the gun, it is because of the internal forces. It is not because of the external forces. So what I can say in this particular case, initial momentum is equal to final momentum. Initial momentum is equal to final. Net external force is zero. Initial momentum is equal to final momentum. So my dear NEET aspirants, don't you think that final momentum also has to be zero? Why? Because net external force is zero. Now, guys, finally we say when bullet is fired from the gun, bullet moves in the forward direction, and we say a recoil of the gun takes place. Recoil means gun moves in the backward direction a bit, not that much. So that is what we call the recoil of the gun. Why does this actually happen? To conserve the momentum. Because if momentum of the bullet is forward, gun must have the momentum in the backward direction. Net momentum must be zero in this particular case. Net momentum must be zero in this particular case. Then, my dear NEET aspirants, we say finally, net momentum is equal to zero. That is, momentum of gun will be equal to the momentum of bullet. Okay, so momentum of gun, that is mass of gun, that is m, into velocity of gun, that is vg, has to be equal to mass of bullet is small m, velocity of bullet is vb. So here velocity of gun will be equals to m into velocity of bullet divided by mass of gun. So this is what we call recoil velocity of gun. With what velocity gun is going to recoil? Gun is going to move in the backward direction. Okay. This will be the recoil velocity of the gun. This is going to be the recoil velocity of the gun. Okay, this is going to be the recoil velocity of the gun. Okay, so in case of gun bullet system also, we say momentum remains conserved. Initially, momentum of the gun and bullet is zero. Finally, also it has to be zero. So if bullet moves in the forward direction, gun has to move in the backward direction. That's why gun pushes your arm backwards. So that is because of the recoil. Now, guys, take a look at the question. This is a very important question. Take a look at this question. Okay. Okay. Before this, I need to tell you something more. Something more. Wait. I need to put it here. Okay. I need to put it here. Okay. See, guys, take a look. One more important thing I forgot to tell you, that is, we say whatever is momentum of gun, same will be the momentum of bullet. Whatever is the momentum of gun, same will be the momentum of the bullet. Okay. Yes. Now, guys, as when it comes to the kinetic energy, that is p square divided by 2m. So momentum is constant. Momentum is constant, conserved. So we say kinetic energy is inversely proportional to mass. Kinetic energy is inversely proportional to mass. Okay. So what does that mean? The one which has more mass has less kinetic energy. So can I say kinetic energy of bullet will be greater than kinetic energy of gun? Absolutely, sir. Because we say mass of bullet is less than mass of gun. That's why it has more kinetic energy. Okay. Okay. Now, if somebody says, sir, where does this equation actually come from? Please give us the explanation. See, kinetic energy is 1 by 2 mv square. I have told you in this in the work power energy lecture also. Multiply with m and divide with n. So kinetic energy will come out to be m into m is m square v square divided by 2m. So what is m into v? Mass into velocity. That is momentum. Mass into velocity is momentum. So kinetic energy will be, that is p square divided by 2m. That is p square divided by 2m. I believe this is crystal clear to each and every single student. Let's take a look at this particular question. A bullet of mass m, a bullet of mass m, take a look, guys. A bullet of mass m is fired from a gun of mass m. A bullet of mass small m is fired from a gun of mass capital M. Gun has the mass of capital M. Bullet has the mass of small m. The recoil gun compresses a spring of force constant K. Basically, guys, this is a gun. This gun is actually firing a bullet. It is firing a bullet of mass M with velocity U. And gun is being pushed in the backward direction. Okay. Mass of the gun is M. And there is a spring connected to this. There is a spring connected to this. There is a spring connected to this. Okay. And it has a spring constant K. It has a spring constant K. The question says that the recoil gun compresses the spring. So when gun comes in the backward direction, moves in the backward direction, comes back. So it compresses the spring. By what distance? By distance d. It compresses it by distance d. Then the recoil velocity of the bullet, then the then the velocity of the bullet is, we are supposed to find velocity of the bullet. Okay, yes. Now, guys, this is a very good question actually. In this particular case, first and the foremost thing, could you please tell me what is the recoil velocity of the gun? We say as a recoil velocity of gun. What is the recoil velocity of gun? Sir, recently we studied recoil velocity of the gun is this. Mass of bullet, velocity of bullet into mass of gun. Okay. That is Vg is equal to mass of bullet divided by velocity of bullet. Okay. Into mass of the gun. So that is it. MVB. Okay. MVB upon M. Sorry. Okay. This is the question. This is the question. This is the question. Now guys, take a look. So velocity of gun is mass of gun, sorry, mass of bullet, velocity of bullet, mass of gun. So what can I write over here? In this particular case, mass of bullet is m, velocity of bullet is u, that is what we need to find, and mass of gun is m. Okay, yes. Now guys, listen to me very carefully. Listen to me very carefully. We say when gun recoils, due to the recoil of the gun, we say spring is compressed. Spring is compressed. Okay. When gun basically recoils, spring is compressed. So can I say kinetic energy of the gun, kinetic energy of the gun is stored in the form of potential energy of the spring? Sir, how? This is the concept which I have told you in the work, power, and energy. The concept is, if let's suppose there's a spring, if you pull the spring with the external force, you do the work done. So that work done is stored in the form of potential energy. Potential energy of the spring is 1 by 2 kx square. Now, so here it was external agent due to which, here it was external agent due to which gun was compressed. Here it was external agent due to which gun was compressed. Sorry, spring was compressed. So here it is the gun which is compressing the spring. So due to the gun, we say due to the kinetic energy of the gun, potential energy will be stored. So I can say here kinetic energy of the gun of the gun is stored in the form of your kinetic energy of the gun is stored in the form of potential energy of the spring, is stored in the form of potential energy of the spring, is stored in the form of potential energy of the spring. Absolutely, sir. So my dear NEET aspirants, what I can say over here, so kinetic energy of the gun, that is 1 by 2 m velocity of gun square, sorry, speed of gun square. This is kinetic energy of the gun. Okay, this kinetic energy of the gun. And it will be equals to potential energy of the spring 1 by 2 kx square. Absolutely, sir. Now, what I can write 1 divided by 2. Okay, 2 and 2 will be cancelled. So I don't have to write this 1 by 2. So this 2 and 2 will be cancelled. So mass m, okay, mass m. And my dear NEET aspirants, mass of the gun is capital M. So I'll be writing capital M. Velocity of gun. Velocity of gun is this. It's square. So it will be mu divided by m whole square will be equals to kx square. So this will be m into m square u square divided by m square. Square and this will cancel out, will be equals to kx square. And instead of x, I can write d because x is given as d. X means how much the spring is compressed, that is d. So I can write over here, this will be u square is equal to, take this m over here, this will be m k into d square divided by this m square. Okay, now u will be equals to under root of m k d square divided by m square. Now for d square and m square, root will be cancelled, so it will be d divided by m, then under root of mk. This is going to be the initial velocity. This is going to be the initial velocity, d by m under root mk, d by m under root mk. So d divided by m under root of mk. So that is option second. I believe this question is crystal clear to each and every single student. Guys, tell me in the chats if this is clear. Is this clear? Is this clear? Okay. Now we are done with, guys, the center of mass concept. Okay. We are done with the center of mass. Okay. Done with COM. And one more important thing, guys, now we have collisions. So collisions, I will be putting the recordings. Okay. So just one recording of 1 to 2 hour, in that collisions will be finished. Just collisions. In that collisions will be finished. So till here, we are done with center of mass concept. Now collisions will be in the recording. That will be in the part 2 that I am sharing by tonight itself. That I am sharing by tonight itself. Keep that thing in your mind. Collisions I am sharing by tonight itself. Okay, so we are done with center of mass portion. Take care and bye bye. Thank you so much. See you guys tomorrow. See you guys tomorrow. Tomorrow we have rotational motion. Okay, rotational motion. So that is very important, my dear NEET aspirants. I would want you guys to be present in the tomorrow session. It is already scheduled on the channel. Let me just show you. It is already scheduled on the channel. Here it is. Here it is. Here it is. Take a look. Rotational motion is already scheduled on the channel. So I would want you guys to go and smash the like button on this particular session. So I will see you tomorrow. We'll be finishing the rotation also. Center of mass, I have told you every single concept. I did not skip any of the topics. Every single concept. Now collision portion, I'll be putting the recording. So you watch that. So take care and bye-bye. Thank you so much. And I'm ending the live stream and I'll be sharing the notes also. Please, everybody of you, do let me know in the comments once I end the live, how was the session? Take care and bye-bye. Thank you so much. Thank you so much.